reactor is all the time aerobic?
Yeah, it has to be, because if the blower or something dysfunctions, that it's not aerated, the worms will die immediately.
This happens sometimes.
Yeah. When he gets very mad.
Big mess. Going at 10 meters.
Yeah, this is the net material. These are the worms, basically. These are digested for the yield is very high. All the volatiles are almost destroyed. So yeah, it basically gives us a direction for, because solids are converted to worms, and these worms are easy digestible. This staafdiagram. This is the input from the worm reactor. When it leaves the worm reactor, 20% is eaten by the worms. What next happens is this part is digested in my bottles, and this. So the results indicate here's 24%. I'm not sure if you can read it. And here at 16% is digested by anaerobic digestion. This means that even though the 20% of the volatiles are eaten, not 20% less is digested in the anaerobic process. So the worms are basically eating something that is difficult to digest anaerobically. The total amount of increased degradability compared to only digestion is 50%. So if you combine the worm process and then you digest it anaerobically, you lose 50% more solids.
So the anaerobic digestion is the same with normal sludge and pre-dilated sludge? Namely, what was your result?
Yeah,
30% or something?
Yeah, let's see.
37%?
So here indeed, I could have told you here better maybe, but when you have not predated it by worms, the fraction of volatiles is the same that is destroyed. So here you have volatile solids, there are less volatile solids because the worms ate it, and yet the fraction is the same. So the worms are eating something that is not easily digested anymore.
So that 16% in your next slide is the 37% of the residual.
Yeah, because this is
because it's not really clear, I guess.
This is because this 16% is taken over total solids here, and before it was over the volatile solids. So that's just a small discrepancy I made, but this is 37% of volatile solids, and this is also 37% of volatile solids. And if you take it over total solids, it's I'm almost come to my conclusion. We proposed 4 mechanisms why this digestion has increased. It could be some enzymatic process, or some kind of bacteria that is introduced into the system because the worms are there in high amounts. And we are not sure. I can tell you the team is moving towards this, that it's some kind of enzyme introduced into the system, increasing hydrolysis rate of the substrate. But when I look at my results, it is important that the nitrate is introduced into the system, and it seems that the worms are increasing particle size, because when you want to hydrolyze something and the parts are smaller, there is more area. So the hydrolytic enzymes have more surface area to attach to, and therefore it goes faster. Why do I think this? Because another one of these big tables, but I'll just point it out. I took 2 different samples. The first sample I took, there was no reduction in the worm reactor. So basically it means that the input from the worm reactor is kind of the same as the output, because the worms did not do much, the worms were dead. Yet, in my opinion, the enzyme should still be there, but there is no difference. The same amount of volatile solids, the same first rate digestion constant, the speed of the process. So nothing happens. Then you have 20% reduction. The worms ate 20% of my solids. Then you can see that it's still the same. Meaning that here something did happen, because you would expect that the digestion of the anaerobic digestion would be 20% lower because 20% of my food is gone. Yet it is not. It's about the same. So it looks like, in my opinion, that yeah, if it was enzymatic or some bacteria, that something would happen here. And if the worms are basically decreasing particle size or doing something with it in their gastrointestinal tract, then yeah, you see this. Okay, it's not clear. I will.
But what is the lifetime of an enzyme?
How long will it last?
Depends on the enzyme.
Yeah, I think quite long. But if it's, yeah, it could be washed out. That's also, and important is, of course, it was one sampling. So maybe if I do it again, that's the problem.
If there's 0% reduction in your worm reactor,
Yeah.
that means that the worms are not degrading anything. So they don't have any active enzymes at that moment.
I think the worms will still be
I
I think the
if
enzymes
they're
are still
there,
active.
they're not active, the enzymes, otherwise they would degrade them. So that means there's no active
No, because
activity.
that's why I say it could be the worms. Look, you have flocks, you have structure of your substrate from your sludge. This could be made smaller or more easy accessible, like worms do in natural worms.
But you can also have, if you have 20% reduction in your worm reactor, that means that there are a lot of worms eating sludge and digesting the sludge, producing a lot of enzymes to digest it.
Yeah.
And then afterwards you get a big inflow of enzymes into your storage
But
tank.
would you not expect the worms are dead? They are washing out. I have these dead worms in my house. You would expect some difference, but yeah.
Yeah, but if you do a batch test in which you add enzymes only in the beginning, then these enzymes are finished after some hours, and then for the other 50 days you have a normal.
Yeah. Okay.
So I don't know the lifetime of these enzymes, but this must be very important.
Yeah.
So that's a good question.
Right.
If these are internal enzymes and they are enforced to be released into the medium, they will be inactivated very fast. But if these are external enzymes, they are glycosylated and they stay, as soon as they attach to the polymers, they can stay very long time in this case because they are protected.
So how could we test this? Because if you then open the worms and you take the enzymes, they will die.
If they are coming from the worms, but they are not of the worms but of the bacteria which are sitting in the gut of the worms, they can be extracellular still.
Yeah.
So they have long residence time, they long lifetime.
Okay. So yeah, could be anything, but yeah, we are leaning towards enzymes as a T. Yeah. Okay. Yeah. Conclusions. The worms are reducing anaerobic digestion resilient volatiles, so biological material that is not easily anaerobically digestible.